All right, so today we're going to talk about two fundamental branches of statistics, descriptive statistics and inferential statistics. We're going to focus on descriptive statistics. Later on, we can have the inferential statistics. So what we're going to do here actually is that we're going to tweak our MS Excel sheet a little bit to make it look like, something similar to SPSS. So before we're going to do that, let's first talk about what are the measures under the so-called descriptive statistics? And what is descriptive statistics all about? So actually, when you talk about descriptive statistics, this involves summarizing and organizing data in a way that makes it easy to understand. And this type of statistics actually focuses on describing the characteristics of a data set. So we are just within the data. We are not, going out, or we are not going beyond the data. And the main purpose is to summarize or describe the main features of a data set, and it provides simple summaries about the sample and the measures. And the most common ones are the averages and, of course, the variability or the dispersion. When I say averages, actually, we call this as measures of central tendency. And the most common one is the mean, or we call this as the average, and the median, which is the middle value. Mode is the most frequent value or the most famous score in a particular data set. Now, the measures of dispersion or variability, this consists of the range, the variance, standard deviation, and this also includes the minimum, the maximum, as well as the coefficient of variation, which we can talk about later as we move along. And in descriptive statistics as well, we include actually data representation using tables, charts, and graphs like histograms, pie charts, bar graphs, and scatter plots. So let's proceed to the Excel sheet and see how we can tweak our spreadsheet and include some other measures which are used in SPSS. Okay, so let's go there. So assuming this is our data set, for example, and we're going to display our descriptive statistics at one go, what we're going to do first is to copy and paste all our scores or values, put them in one column. So just copy and paste, put all the values in one column only, because we cannot have the accurate descriptive statistics if the data set is in table format like this in various columns. So already I put the numbers in one column here to save time. So in your case, in reality, what you're going to do is to copy and paste in such a way that you will have only one column data set. Okay, so this is the first step. Now, as I said, we have to tweak our uh, spreadsheet by clicking on File, click File, and Options. So again, click File, Options, and here you're going to proceed to add-ins. Okay, click add-ins and click Go here. This is Excel add-ins. Okay, there are some other options there, but by default it is Excel add-ins. Click Go. And this ones you have to tick all of this because usually these are not ticked. So please tick all of this, then click OK. The moment you do that, when you click on data, these two will be added, data analysis and solver. These were not there at the outset. Okay, so the moment you change or you add this particular option, File, Options, then Add-ins, Go. The moment you add all of these, click OK, you will be seeing both of this, the data analysis and the solver. So data analysis is for the measures in the statistics, And solver is usually for linear programming, okay, where we optimize our objective function. So it could be to minimize or to maximize. That's the optimization when we talk about linear programming. We either maximize or minimize. Okay, so solver is not our topic today. What we're going to talk about today is the data analysis. So we're going to display the measures of descriptive statistics, okay, or under descriptive statistics using this data already converted into one column. So we have to click on data, home data, data analysis, and type D, because sometimes it will be here or it might be somewhere. So type D is going to select descriptive statistics and then click OK. So here, very simple, you have to delete that input range. Okay, select the input, the column. You can include the title as well. Okay, or you can start from the first score. Okay, now if you included the title, for example, you have to tick this one, labels in first row. But since I started with 20, I did not include a title, so I don't need to tick this. And this can be changed to rows or columns. By default, it is already ticked as columns. Okay, if your data is given in row, you have to tick the rows. Okay, so that means that this particular data here in the table can be converted into one row or one column, but the most common way of doing this is to change our data set into one column. All right, so that's why by default it is ticked as columns. And here these ones are not ticked originally, so you have to tick all of these: summary statistics, confidence level, the kth largest, kth smallest. Okay, that's it. Okay, and you have to take this output range. This one, you have to delete that. And here, you have to put the cursor here and select the first cell where you want to put your answer. You can select this or any of the cells here. Okay, it's up to you actually. And click OK. Immediately in seconds, you're going to see all the descriptive statistics. So it saves a lot of time. Many people don't know how to do this, so this is a very important skill. Why? Because it saves a lot of time. Actually, if you're going to do this, if you don't know, for example, how to tweak your spreadsheet, you have to calculate the mean, median, and other measures separately, which takes a lot of time. For example, the mean you're going to use equals average. Okay, select the values, enter. You're going to see why the mean is different here. Let me just, okay. Okay. It's not giving me some values. Average. Okay. 39.61. Yes. Make sure that you select all the numbers accurately, or you can also test by selecting the values in column. Okay. It's the same. So this is the manual. Be careful, sometimes instead of average, you might be selecting this. Of course, it will give you a different answer. Okay, this is the correct function. Okay, so select this. The median, for example, equals median of this. Answer is exactly 40, which is the same. So see, just look at the amount of time that it's going to take if you're going to do it manually compared to the approach here. We just changed a little bit by clicking on file options and so on. We're able to display the measures in seconds. Okay, so you can rewind, you can pause, you can forward the video and try this on your own. I'll be sending the file as well so you can practice on your own. Now let's just look at the values here and try to interpret, because in the statistics actually it's not about the values, it's about the interpretation the meaning of the values. Now, the mean is the most common measure. It gives you an idea about the data. 39. And look at this data set here. What is this all about? What is the variable? So variable is very important. When I say variable, or we call this also as category for qualitative data. For quantitative data, actually, we call it usually variable, but also we can call the scores or the type of data set we're measuring in qualitative data as variable as well, or factor usually. Okay, so variable is what we are measuring. Here we measure, or what we are analyzing. Here we talk about marks of students, and the base is 0. So it means the starting point here is 0. And 39 actually, if the base is 0, is fail actually. So 39.6 approximately, this is 40 D minus. So at a glance, we can already tell that these results of students are not good because the mean is 40, So 39.6 close to 40, not even, 40 exactly. So this gives us an idea that most of the students failed. Okay? And let's look at the median, for example. Median is close to the mean, 40, and the mode is 40. So the median would tell us that 50% of the students approximately are below 40 and 50% are above 40. So it means that half of the data set, or half of the number of students here failed. Okay, and half passed. So roughly you can already say that 50% of the students only pass this particular assessment, for example, or pass the particular module. And the mode is the most common score, the famous score, 40, is repeated several times. So if you're going to highlight the table, conditional, okay, text that contains or equal to 40, you can see that 40 is repeated several times. 1, 2, 3, 4, 5, 6 students there. Okay. So that's the meaning of these three values. Central tendency. They tend to be at the middle. Okay. Especially the median is exactly the middle value. The mean, the mode will be somehow close to the median, but not always, because they're affected to the outliers. And that's the main reason why we call these as measures of central tendency. Standard deviation is 21 point something. What is standard deviation? It's just telling us, the average distance of the scores from the mean. That is the simplest definition of standard deviation. It is the square root of the variance. So we're talking about, the average variances, distance from the mean. So we can use the standard deviation actually to calculate where is the concentration of the data. So mean minus standard deviation, and the mean plus standard deviation. Okay. So let me make this bigger. All right. So equals the mean minus standard deviation, this one, and equals the mean plus standard deviation. So 18 to 69. So you could say that, okay, the large proportion of students, or students' marks, because this is about students' marks, are cluttered around 21.077 from the mean, between 18.5 and 60.69. So what's the meaning of this? This means that the concentration of the data is between 18.5 and 60.69. most of the students there, approximately 68%. Okay, in statistics, if the data is normally distributed, this is approximately 68% of the data, and it could be more as well. This is the concentration of the data. So standard deviation is very important because it will tell you where is the large proportion, where is the concentration of the data. We can check this using conditional formatting by highlighting our table and conditional highlight between this and this. Okay, so you can see here that there are many students there obtaining 18.5 until. So you can also tell that really this is not a good performance during this particular semester, for example, or if this is a particular subject or module. Okay, so that is the use of standard deviation. Okay, variance anyway is just a tool to get the standard deviation. Okay, it is like the square of these. Now, skewness is positive, for example. Okay, so we have positive 0 point something. What is the meaning of that? If it is positive or if it is negative? Now, we cannot say that if the skewness is negative, then the performance is bad. No, it depends on what we're measuring actually. Here we talk about marks of students. So positive. If it is negative, you will see negative here before 0. Okay, so let's go there, skewness. Okay, so we have here positive, symmetrical. Symmetrical, this is usually difficult to obtain. Okay, where we have somehow balance left and right, symmetrical. This is the positive, this is negative. When you say positive, lower frequency on the right. So lower frequency on higher values. For example, this is 0 here until 100 because we talk about the scores of students. Most of the students are here. Okay, they obtained lower marks, and a few students obtained higher marks. Okay, so which is bad, a bad performance because only a few students obtained higher marks. Now, if you talk about prices, for example, and it is positive, then it is good because most of the prices are low and only a few items, for example, are worth higher. Okay, so it depends actually on what we are measuring, what we are talking about. If it is negatively skewed and we talk about marks of student, then it is good because only a few obtain lower marks and most of the students obtain higher marks. Okay, but this is actually our target, balance left and right. All right, so that's the meaning of that. Of course, minimum is the lowest, maximum is the highest. So you can see that the lowest score is 0, highest score is 93, and range is the distance between the lowest and the highest. This is just the sum, adding all the scores, and the largest and smallest also same with minimum and maximum. Okay, kurtosis, we can talk about it later actually. It is about the shape of the graph. Okay, so you can see here. Yeah, so we have 3 types as well. Same with the skewness, we have also 3 types. We have symmetrical, we have the positive and negative. Here we have the mesokurtic, platykurtic, and leptokurtic. This is about the tailness of the distribution actually, and this will tell us whether we have outliers or not. Okay, so usually we look at values between 0 to 3 and 0 to -3. If the kurtosis lies between 0 to 3, 0 to -3, here is very small. Okay, 0.0.3. So we could say that there are no outliers. When we say outliers, these are numbers which are very far, okay, or we say very big or very small and away from most of the scores. Here, for example, if we're going to put this as 490, it can be an outlier, and there is no 490, of course. By mistake, for example, this is 490, it's going to change everything there, okay? So, of course, this kurtosis will be changed. So the practical one, okay, acceptable is from 0 to 3 and 0 to -3. Between -3 and 3. After that, you have to look at your data set. This would tell us that there are some outliers. Okay, so let's go back there. So our target actually is the green one, the mesokurtic. Okay, medium kurtosis, for example. Okay, and of course you would be happy if it is platykurtic, that means low kurtosis. Okay, like these, that means very, very small. Okay, it means we really expect that there are no outliers. Of course, this leptokurtic, for example, high kurtosis. Okay, as you can see here, the blue one, it means that we have some outliers. Okay, that's it for the first session. This is about descriptive statistics, and I hope you learned something. Thank you so much. Until the next time, bye-bye.